All right, so today I'm going to go over how we handle piecewise functions. So piecewise functions are functions that are different depending on the domain of the function, meaning the input or the x value. So if we look here at 1a, they want us to find f of 0, right? So that means that our x value is equal to 0. So we're going to go here and take a look at this piecewise function and figure out, are we going to use the first function or the second function? Well, when x is equal to 0, we have, like, if we test this first one, right, is 0 less than or equal to 2? That is true, right? 0 is less than or equal to 2, so we would use the first function. The second function, right, is 0 greater than 2. That's false, so we wouldn't use the second function. So you use that domain here on the side to tell you which function you use depending on what your input is. So we're going to plug in a 0. So we've got -2, and then I plug in my x value of 0 squared minus 1, and you can go plug that into your calculator, and when you get that, you should get -1 as your output. Then we're doing f of 5. So we look, are we going to use the first equation or the second equation? Well, is 5 less than or equal to 2? That is false. Is 5 greater than 2? That is true, so I'm going to use my second equation. So I've got 4/5 open parenthesis times 5, and then minus 4. We can plug this into our calculator, and when you plug this in, I'll show you how to plug this in if you don't know how. To plug in a fraction, we'll do open parentheses, 4 divided by 5, close parentheses, and then we're going to do times 5, and then minus 4, all right? And you end up with 0. The reason for that is you end up here with like 4 minus 4. This gives us 0. All right, and then we've got f of 2. So here, right, we have to look. Okay, is 2 less than or equal to 2? That is true. Is 2 greater than 2? That's false. So I'm using this first equation. So I've got -2, and then I'm plugging in my x value of 2 squared, and then minus 1. So I'll show you how to plug this into your calculator if you don't know how. We do -2, open parentheses, 2, close parentheses, squared. Remember, whenever you're plugging into a function, always put parentheses around whatever you're plugging in. And then we do a minus 1, and we end up with -9 as our answer there. Here we are plugging in a -3. So I look, am I going to use my first equation or my second equation? I'm going to use my first equation because -3 is less than or equal to 2. So I end up with a -2. I plug in a -3 squared, and then minus 1. So again, I can just plug that into my calculator, or of course, if you can do it in your head, that's super. So we end up with a -19 as our output. All right, let's go ahead and let's see. We will do, I don't know what would be a good one for us to do here. We'll do 6. All right. So here we're evaluating a piecewise from a graph. Before it was like from the actual like written algebraic function. So here I need to go to an x value of -3. So I go to an x value of -3. My output here is -3. Here I've got an x value of 4. So I go to an x value of 4. My output is 4. F of 1, my x value is 1. I look at my output is 1. And here, okay, f of -1, if I look, there's an open circle there, and there is no closed circles anywhere, right? So this actually would be considered undefined. All right? And then f of 0, my output here is 0. Now, real quick, let's take a look at 5. Let's say they wanted us to find, let's go do D real quick. Let's say they said f of -2, so that's an x value here. Well, we have this closed circle and this open circle. When you have a closed and an open, you're going to go with the closed, okay? Your output is always whatever the closed circle is, so in this case, it should be a -1. If, let's say, both of these were open, I'm just changing it here. If it was like this and they were both open, you actually would put undefined because we don't have any closed circles there then. But it was closed, so our output there is -1. All right, and then let's see. We will go ahead and I will do 12 here as a example. So I'm letting you guys use Desmos to graph this. So I definitely would recommend using Desmos, and honestly, I would follow along with me as I do this to make sure that you can plug this into Desmos on your own so that you can do it on the quiz and test. So when we plug functions into Desmos, we're gonna, you see how this has like f of x? Instead of doing f of x, we'll just do y equals. So we'll start with the first one. We do y is equal to, and then I've got 2/3 x plus 3. Now what this does is this graphs the function for all values of x, okay? However, I only want this to graph the values for x values less than or equal to 0. So the way that you get it to do that is you need the swirly bracket. So if you click on the keyboard on Desmos and click ABC, down here next to the brackets, you'll see these swirly brackets, and you put that in there, and then you're going to type in x, and you can see they have the inequality symbols. So I'm going to do x is less than or equal to 0, and then I go to ABC, shift, and then I can close it. So what it does then is it only graphs it over the x values that I want, okay? So I'll go ahead and graph that portion now. So what you want to do is look at, you can like use your cursor and slide it across here. You can see here that its starting point is 0, 3, okay? And if you look at 0, this first function is filled in. So you got to make sure you fill that in. Then you got to find, I would say, at least one other nice point, right? So you can kind of slide around. Let's see, that one's a decimal, so I guess let's try and I'll show you at least how to find one other nice point. So if you like slide this around, you know, ones that look like they're nice points, if you go kind of slow near them, you can actually find, you know, nice points that you can plot. So in this case, I could use -3, 1. So I'm going to go do that. So I go 1, 2, 3, 1. And as you can see, this guy goes on to -infinity, right? It goes on forever in this direction. Obviously, Desmos goes on forever, right? You can scroll to the point where you keep going, but on your paper, it doesn't, right? So you can't just randomly stop anywhere you want. What you do is you draw it like this, and then you have to add an arrow going in that direction, okay? You cannot add an arrow going in this direction because it doesn't go forever in that direction. It clearly has an endpoint. All right, and then we've got our second form of the function. Again, make sure that you do y equals whatever your function is here. So in this case, it's just y equals 3. If you don't do y equals 3, it's not going to plot it. You need that y equals. And then we want it for x values between 0 and 2. So we do ABC, swirly bracket, and I'm going to do 0 is less than, x is less than 2. And then I do close that bracket. All right, so you can see here it plotted this portion for me. And let's see, this guy, at 0, he is open. However, when you have an open and a closed overlap, it just stays closed. Okay, so like that, this is just a closed point here. I guess actually what I'll do to not confuse you is just draw it in the same color, so you can see that it is just still closed. And then we go over here to 2, and at 2, this function is open. So we need a very clear open circle there. Then we have our little last bit. We've got y equals. And again, make sure you know how to plug this into your calculator, into your Desmos. If you don't know how to do it, you're going to get, you know, an easy question wrong on the test and quiz. So we do open brackets, x greater than or equal to 2, ABC, close that up. All right, so now you can see here, this is our last little bit. And of course, right, you can kind of slide around, get some points. You always want to have the endpoints in there though, right? So 2, -1. So I'm going to go 1, 2, -1. And then I am going to close this guy because he is equal to, so he's closed. And then I need another point. So I can slide around until I get a nice point. So I can see here, it's coming, come on. Let's see. And you could always zoom in. All right, so here I got 4, -2. So 1, 2, 3, 4, 1, 2. And again, this goes on to infinity, so I have to make sure I put an arrow in there to show that.